Hello, welcome to College Algebra Section 5.4. My name is Rob Reynolds, and we're going to be looking at rational inequalities today. So we just got done looking at how to graph rational functions. Remember, there was four or five good steps to find the vertical asymptote such that the denominator equal to 0. To find the horizontal asymptotes, we look at the degree of the numerator. If it's less than the denominator, it's at y equals 0. They're the same. We do this a over b, and sometimes we have to have an oblique asymptote. For x-intercepts, we set the numerator equal to 0 only if there's no d shift. That would be something that looks like this, a plus 5 at the end. And then the last is to let every x be 0 to find the y-intercepts. So this page is talking about the domain. So the domain here would be all reals except x can't be where the vertical asymptote is at, plus or minus 3. Here, all reals except x can't be 2. Here, we got a volcano effect. X can't be negative 2, but remember, this is going to be a volcano where over here we're alternating. One side's going to positive infinity, the other side's going to negative infinity. This causes that volcano because you're double asymptote down there. And here it's all reals except, again, x can't be 1. And it would alternate because that's odd. So we got done looking at 5.2, 5.3 by locating the vertical asymptote, the horizontal asymptote, the x-intercepts, and the y-intercepts. And then with that information, looking for removables, double asymptotes, and how to graph. So now we're going to move into how to solve some inequalities. And we did this before with linear functions, but now we're doing it with polynomials. So I would set it equal to 0. I know I'm going to confuse some of you because I'm just changing this less than sign to an equal sign, but we're just going to find the critical values. And a critical value would be happening where there's a 0 or there's a vertical asymptote. So I just want to know what are the critical values here. So I'm going to factor out an x squared. X squared is what I'm going to continue to factor some more to find all of my critical values. So it looks like I've got a critical value of 0, but it bounces at 0 because it's squared. I've got critical values at plus or minus 2. So I would place all of your critical values down in order on a number line and then run some tests. And the first thing, I could test a 3, anything outside. I'm going to test a 1 because it looks pretty easy to test a 1. And I'm going to go back to the original and just see if 1 to the 4th, which is 1, minus 4 times 1 squared is a true statement. And it is true. Now, normally, it's going to alternate. Every time you hit a critical value, what the heck is a critical value? Well, it's usually a root where the function comes down and it changes from positive to negative. And it's usually, you just alternate. Once you find it's true, on either side it's going to be false, and it's true. However, because this is a double root at 0, because this thing is being squared, I know this thing does not alternate true, false, true, false. If it's a double root, remember it's going to bounce. So I know that this side, if this is true in between 0 and 1, you can test if you'd like. It just takes longer, but I don't need to run a test of negative 1 because I know that it's bouncing. So if this side is true, then this side is true, and then this will be my false. So I would say my final solution is between negative 2 and 2, and since they use an equal sign, I can include those values. The book's going to ask you to graph a number line, but I will ask on the test just to give the interval notation. Let's try it again. Let's set this thing equal to 0. I'm subtracting off x. Again, I'm changing inequality because I just want to find the critical values. If you factor out an x, that's x cubed minus 1, which does factor some more, but I'm just going to set it equal to 0 and take the cube root. So I get a critical value of 1, I get a critical value of 0. The other critical values here are imaginary, which I'm not going to worry about the sign changing for imaginary roots because they have to be real roots for the sign change. So I need to test something. I'm going to test something beyond. I'm going to test 2 because I don't want to test 1/2. So 2 to the 4th is a positive. Well, obviously this is going to be greater than if I throw in here. So this is going to be true because this is going to be a greater number than this. So that is true. Now it looks to me like these are odds, so they're going to alternate true, false, true. So this time my solution is from negative infinity up to 0 and then 1 to infinity. So I would write this on my test. Up to 0, I'm looking here to see there's no brackets because it's not equal to it, and then 1 to infinity. Sometimes you see this in union sign. The book is asking you to graph, but I'm not a big number line grapher, so I would just have it in interval notation. When you have rational expressions, the critical values come from the numerator and the denominator because In the denominator, you have a vertical asymptote, and of course, it's going to switch from positive to negative, but not in this case because it's a volcano effect. That thing is being squared. But my critical values, nonetheless, are still -3. This critical value is confusing. It's 2 minus 2 that equals 0. So 2 is the critical value. When you set that thing equal to 0, you could work it out, but I can just tell that x is 2. The number 2 right here is what causes this factor to go to 0. And then the other critical value comes from the denominator, which is a 1. So I'm going to use all of my critical values coming from the x-intercepts numerator and the vertical asymptotes denominator to place them on my number line. Don't worry if it's not spread out evenly. I know that the distance between 1 to 2 is not the same as 1 to -3, but that's not the point. I'm going to find a critical value and then look for single roots and double roots to see if it switches from true to false on singles, and it's going to stay the same at double roots. So I'm going to test 0. So throwing in a 0 here, I get 0 plus 3, which is 3. 2 minus 0 is 2, all divided by -1 squared is 1. So I really end up with 6 is greater than 0, which is a true statement. So I tested 0, I'm going to locate 0, and think everything in here is true. Now, right here is a double asymptote, which means it's not going to change sign just like a double root, because remember that causes the volcano effect. So I know it's true on this side as well. This is a single root, so it's going to change from true to false, and this is a single root coming from this guy. So again, my true values are between -3 and 2. The tricky part here is if this was, well, that's interesting there. 1, this is tricky. I can't say that this is the final answer because remember, this is a vertical asymptote, which means I need to exclude that. So it needs to go from -3 up to 1. I have to exclude 1 because I got a vertical. I can't let x be 1, I'll divide by 0. And then 1 all the way up to 2. So even though this looks like it's a between -3 all the way up to 2, I've got to figure out how to exclude that 1. And the only way to do that, good, the book threw a 0, that's nice. So from -3 to 1, and then from 1 to 2, I had 2 different intervals. So again, critical values can only be set equal to 0. Do not set factors equal to 3. So for this one, we're going to have to subtract off 3. And that's like subtracting off, I need to find common denominator. So I'm going to multiply the numerator and the denominator by x plus 2 to find my common denominator. So what do I have? 4x plus 5 minus 3x minus 6, all divided by my common denominator. All I've done here is distributing my -3 and came up with my -3x minus 6. Combining like terms, I have x minus 1 over x plus 2. So it looks like my critical values come from the numerator, x-intercept of 1, denominator, vertical asymptote of -2. I'll plot those in order on my number line. I'm going to test 0 into the original function, and I'm going to find out if 0 is true or false. So 5 divided by 2 is 5 greater than or equal to 3? False. So I know that every value between -2 and 1 is false. Looks like these are single roots, so I'm going to say true and true. So my final answer would be -infinity to -2. Now this is interesting. I can't include the asymptote here, so parentheses on the asymptote, but I can include the x and here it is. Let's look down here because this is my new function. I can't look at this because it's not set equal to 0. So here's my vertical asymptote. I can't include -2, but I can include this 1. So I'm going to say from 1, and I'm going to bracket the 1 all the way up to infinity. So remember, you can never include infinity, and you can never include where a vertical asymptote is at. Why is this bracketed? Because that's an x-intercept, and you can include that. So good, the author agrees with me. Bracket here on the 1, where it's parentheses on the -2. So that pretty much finishes up this section. It's a short lesson, but remember, you just set each factor equal to 0. Find your critical values. So your critical values are 0, -3. It looks like 5 would set that equal to 0. Put these on a number line, and then start testing. Don't test 0, because that's a critical value. You can test 1 and see if it's true, and then alternate if it's a single root. And if it's a double root, remember, the trues will stay true on both sides, or the falses will stay falses on both sides. So you can kind of run through and see what these multiple choice are all about, and I'll do this on the next section, 5.5. So I hope you join me for section 5.5. Email me for questions. Thanks. Bye.